So what we're trying to do here is we're trying to show that two triangles are similar. There's two triangles in one. So let's separate them. Okay? We have triangle A, B, what? No, A, B, D. I'm going to draw that here just so we can relabel it. I have A, B, D. Do we know the side length of AB? Shh. Do we know the side length of AB? What is it labeled as? Okay. Do we know the side length of AD? We do? What is it? So we know that it's going to be 3.6 plus what? Y. Okay? Do we know BD? What is it? Good. 8 plus 6? 14. I'm not going to put the units here. There's not enough room. That's one triangle. Okay, what's the second triangle in this diagram? C, D. Okay, let's label this. I'm just pulling this out. C, D, E. Do we know DE? What is it? Good, 3.6 centimeters. Do we know CD? What is it? 6.0. I'm just going to write 6. And do we know CE? What is it? Okay, good, 6 or 6.0. So what we've done is we've just separated our two triangles. It's easier to look at now when we need to figure out if they are similar or not. Well, are they in the same position right now? Like, is it easy to figure out which sides correspond to one another? Look at this angle. This is a clue. Is that in the same position? Yes. So they're in the right position right now. They're corresponding to one another. Well, now, I mean, you can use a highlighter. You can use a colored pen if it helps you. Okay, just to figure out which sides are corresponding. Well, DB corresponds to what? Good, DC. DA corresponds to which side length? Good, Pravina. And AB corresponds to CE. We have two unknown side lengths. You always want to use the ratio where you know both of the side lengths that correspond, obviously, because you cannot solve a proportion if you have two unknown values, right? So which side lengths do I have both side lengths? Right, I can figure out the ratio of this triangle should be 14 over 6, right? That's the ratio of all the sides because we're trying to show that they're similar. So let's solve, what do you want to solve for, x or y first? Let's do x, okay? 14 over 6 should be equal to, you always have to go in the same order. I'm going from triangle 1 to triangle 2, okay? So should be equal to x over what? 6, good. Can you solve for x? Cross multiply. Yes. 6 times x. 14 times 6. 84, good. How do I solve for x? Divide both sides by 6. What does x equal? X equals 14 centimeters, okay? So we found the first one. That was easy, right? This is 14 centimeters. Now, you have two options here. You can use this ratio again, or you can use this ratio, since you just found that out. They are the same. But I would recommend using the ratio that's always given, because if you make a mistake here, and then you use it, then your whole answer is going to be wrong, right? So let's use 14 over 6 again. So 14 over 6 should be equal to, what's my other two corresponding side lengths? Should be equal to what? Good, 3.6 plus y over, good. Can you cross multiply? Yes, you can. I'm going to do this on the other page so we have more room. Okay. Page 6 times this whole thing, right? So it's going to be 6 times 3.6 plus y, so we have to use distributive property. Remember this? Is equal to 14 times 3.6, right? So let's simplify. Distribute. 6 times 3.6? 21.6 plus what's 6 times y? 6y, good. What's 14 times 3.6? 50.4. We have one unknown. Yeah, we want to subtract 21.6, so we're left with 6y equals 50.4 minus 21.6. What is 50.4? Take away 21.6. Y. Divide both sides by 6. Y equals what? 8.4? Huh? 0.8? Okay, 4.8 centimeters. Did this y represent the side length? Go back to your original diagram. What was the side length? It was 3.6 plus y, remember? So what's 3.6 plus 4.8? 8.4 centimeters was the missing side length. Which side was that? What letter? It was DA. So, okay, remember here? Side length DA is equal to 8.4 centimeters, and we solved all parts to this triangle. Well, we didn't solve the angles, but we solved all the side lengths.
Made with Doodlecast Pro.